Hey guys, Miss Perry here again. It is time for us to start our new unit. And our new unit is going to be on linear equations and lines. But before we can start that, we need to talk about what rate of change is and what slope is, because the two are definitely related to one another. Some people might even say they're exactly the same thing. They pretty much are. So, what is rate of change? Well, let's first talk about what we're going to be looking at. We're going to be looking at data or information with numbers. And we're going to be looking at that information when you get two sets. And our sets are going to come in the form of x's and y's. Okay, so these can come in the form of ordered pairs. Ordered pairs come in x comma y, the numbers, so like just any numbers for x's and y's, these are integers, okay? They can come in the form of a table, right? So you guys have seen this as an xy table, like xy tables like this, and you put the numbers in like that, okay? So xy tables. It can come in the form of a graph, right? So graphs have an x-axis and a y-axis, and you plot those points on it. And sometimes, and what we're going to talk about, because we're talking about linear equations, we're going to see like lines and stuff that go through them like that. So they come in the form of the graphs. And then later on, not today, but later on, we're going to see what does this look like in the form of an equation. So also an equation form. Okay, and the equation form has x's and y's in it. For example, y equals 3x plus 2 or something like that. So these are the four different ways that you can see information with data with x's and y's in them. So either ordered pairs, table of information, a graph, or an equation. All right, so we're going to talk about these top three first. Oops, didn't want that, I wanted this. We're going to talk about these top three today and how to find what the rate of change is. Well, what is the rate of change? Well, it's a rate. So that means how do the x's change when the y's are changing at the same time? Okay, so that's what's going to happen here. X's are going to change at the same time as the y's do. And how do we figure that rate out? Right? A rate just tells like miles per hour, like how many miles can you go in 1 hour, right? So this rate is how do the x's change when the y's change? And here's what I tell students to look for. Instead of kind of memorizing a bunch of formulas, here's what we want to look for. We want to look for patterns because students are really good at looking for patterns, and it doesn't matter what grade you're in. Students are really good at looking for patterns. And the patterns we're going to look for, now this is going to seem weird. We want to start with y because we want to see how do the y's change? How do the y's change? That's not apostrophe. Do the y's change? And then we want to look and see how do the x's change? All right. And the reason I said y first is to get the rate of change, or sometimes they call it slope. We do the change in the y's, so the y's go on top over the change in the x's. This is also called the slope. This is also called the slope of a line. Okay, so it just tells us how a line is changing when the x's and the y's change. All right. I think it's easier to see in action than it is, but remember to keep in mind that what all we're really doing is how do the y's change and how do the x's change? That's kind of how we're looking at it, and we're going to look for patterns. All right, so let's look at our first example. Our first example is in table form. Okay, so this is in table form. Look at that first. And in this table, our x's are in, I'm going to put them in pink. Our x's are in pink and our y's are in blue. Okay, So what we want to do is we want to figure out, look for the pattern. How do the y's change? Here's what I meant by a pattern. How do I get from 2 to 3? How do you get from 3 to 4? How do you get from 4 to 5? Like, what's the pattern here? Well, to get from 2 to 3, I have to add 1. To get from 3 to 4, I have to add 1. To get from 4 to 5, I have to add 1. So this is my change. Now, I get really lazy about having to write change, but I'll write it. My change in y, I'll show you guys there's actually a symbol that we can use for this. We'll show you that on another day. But change in y is 1. So if we have change in y, well, that's a positive 1 because I had to add 1 to all of these. So like I said, you're just looking for patterns. And then we have our change in x. So how do I get from -6 to -4? Here's where you're going to have to be pretty good with your integers and all that work we did earlier in the year with integers. So if you're not doing well with integers, I always tell students a vertical number line is always a great thing. Vertical number lines work great. So here is my vertical number line. It doesn't have to be perfect, okay? Because all of my, especially when it comes to negative numbers, and they're all negative except for 0. So I'm going to put 0 at the top. And then that's -1, -2, -3, -4, -6, -8. Okay. This one's -1. Oops. This one's -1, -3, -5, -7. All right, so we're starting at -6. So I'm going to put my point down here at -6, and we're going up to -4. That's where we're going to. So if I have to go up to -4, going up is positive, and I had to go up 2 spaces. So my change there is +2 because I had to add 2. Okay. Well, then how do I get from -4 to +2? Well, if I go from -4 up here, that's positive again. Oh, I had to go 2 more spaces, +2. Okay, how do I get from -2 to 0? Well, here's -2, there's 0. I had to go up 2 again. So that's +2. So if you look at this, my changes in x were all the same. They're +2 over +2. So that's a number line helps a lot. And I think vertical number lines help more, even though this is x's, even though this is the x, and the x does go left to right. Vertical number lines are easy to figure out the patterns on because it's intuitive for students to want to go up is positive, and you have to move down, it's negative. All right. Now, how do I write my final answer? Well, your final answer is what is the change in y over the change in x, okay? So I'm going to write this, I'm just going to kind of simplify this, and we'd say the rate of change is, and a positive over a positive is a positive. So we don't need the positive sign. We just say it's 1/2, or some people might write it as 0.5. I happen to like the fractions better. So I would say that our final answer is 1/2 in this problem. So remember, we're just looking for patterns. How do my y's change at the same time as my x's? In this problem, my y's get bigger by 1 as my x's get bigger by 2. Okay, so that's how you would do it with a table. Now, what about an ordered pair? So I have an ordered pair down here. I might move that up. I'm going to move this up a little bit. Okay, so this is my ordered pair. And how do we do this for an ordered pair? Okay, well, remember, it's still x's and y's. And so what you might want to do, instead of, if they're written horizontally like this, what you can do is just rewrite them vertically. So I would say, all right, this is -10, 3, and 5, 0. And all you have to remember is that x's come first and y's come second. And now you kind of have a little table here. We can do what we just did, right? So we said that our x's were in pink and our y's were in blue. All right, so let's figure out our change in x and our change in y. So change in y, my change in y, how do I get from 3 to 0? Well, I have to minus 3, right? So my change in y is minus 3. So change in y is minus 3 or negative 3. How do I get from negative 10 to positive 5? That one might be a little bit harder to do. That's going to be a really big number line like this. All right, so I'm going to put 0 kind of like right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 10 is way down here. 1, 2, 3. Positive 5 is way up here. And I want to know, what do I have to do to get from down here all the way to up here? So I know it's going to be positive because I have to move up, right? I have to move up, so it's positive. So it's going to be positive. But how many spaces is that? Well, from negative 10, 0 is always a good point because from here to here is plus 10. And then from 0, because 0, 10 to 0 is 10. And then from 0 to 5 is a plus 5. So plus 5 and plus 10 make plus 15. So this is plus 15. So my change in x is plus 15. Okay, so 0 as kind of a benchmark is great when you have some bigger numbers that are positive going to negative or negative going to positive. Just remember what direction you're going in, and that'll tell you if your final answer is positive or negative. All right, so now we've got to simplify. You got to remember how to simplify a fraction. I've got a negative over a positive. So I know that's going to be, whoops, I wanted this to be pink. Well, I guess I could leave it in this way, but this is going to be negative, right? Because a negative divided by a positive is negative. And then we have 3 over 15. Well, I can divide by 3 on both of those. Let's get rid of this stuff. And that's going to leave me with negative 1 over positive 5. So it's negative 1/5. It's our final answer. Yes, slopes and rate of change. Slope and rate of change, they can be written as fractions. These two we just did were fractions. 1/2, negative 1/5. They can be positive. They can be negative. They can also come out to be integers or whole numbers. That would work as well. But you get all kinds of different answers. But remember, we're still looking for a pattern. So how do I get from one y to the next y? So to get from 3 to 0, I have to subtract 3 or minus 3. To get from negative 10 to 5, remember, negative 10 all the way up to 5, well, negative 10 to 0 is positive 10 spaces, and then to go from 0 up to 5 was plus 5 more. So those two together gave me the plus 15. Okay, that's going to be the hardest part, I think, for students, is that part with the integers. Okay, so that's how, but remember, it's always change in y. Y is always on top, x is always on the bottom. Okay, so we just did table. We just did ordered pair. Now we still have a graph. What do we do with a graph? So here's a graph. So as a reminder, remember our x's are left and right. So remember, this is our x-axis, and our y-axis is your vertical axis, and that's the one where all the numbers are. Okay, so this is my y-axis right here. And what we're going to be looking at is we're looking at this line right there. That one, I can make that a little bit thicker. Let's make it thicker. I'm going to be looking at that line right there. So how do I do this in a graph? Well, in a graph, remember, we're still looking for how do my y's change when my x's change? Right? That's what we're looking for. How do my y's change when my x's change? So what I need to do is I need to look for points on this line right here, this diagonal line right here. And so I'm going to be looking for any points that are kind of easy to spot. So I'm just going to look on here, This is an easy one where I can find the ordered pairs. So the ordered pair, remember our x is -1 and our y is 3. So this is going to be -1, +3. And I'm just going to keep on following the line, and I'm going to pick another point right here that's kind of easy to come up with an ordered pair. My x is 0 because I don't have to go left or right. I just have to go up 1. So this is 0, 1. And I can find more points. There's one right here. That's 1, -1. There's another one right here. That's 2, -3. So what you have here is a list of x's and y's that are put together, and we would just want to figure out how do the y's change when the x's change. So you could do a table. You could make a table out of these if you wanted to, and do it like we did this one here. So you could just put all those points in a table. Just remember your ordered pairs. These are your x's, -1, 0, 1, and 2, and your y's are 3, 1, -1, and -3. But there's also another way to do this just by looking at the picture. I'm going to zoom in, and we're going to look at the y's. So, because remember, y's go over the x's. So if I want to go from this point to this point, how do my y's change? Well, in this case, I had to go down, right? So this is like almost looking at, this is your number line. That's all a graph is. It's two number lines that they put together. So I had to go down how many spaces to get to that point? Well, I had to go down, which is negative, and it was 1, 2, right? It's like 1, 2, so I had -2. Okay, and look what happens when I do this from this point down to here. Oh, wait, that's having to go down. You can't really see it. You do it in black so you can see it. I have to go down 2. Oh, that's a -2 again. Oh, wait, and then to go from this point down to this point, I have to go down another 2. Oh, guess what my change in y's are? My change in y's are -2, because to go from the y's change, from here to here, it's 2. From here to here, it's -2. From here to here, it's -2. Okay. Then to get my x's, that just means this is where my x's started, and then it's going this way to there. Well, that's a positive direction, and I only had to move over 1. And this is a positive direction, and I only have to move over 1. And that's a positive direction, and I only have to move over 1. So my change in x is a +1. So you could make a table out of them, or you can just look at this as, oh, these are just two number lines that we put together. I've got my y number line, and I've got an x number line. Okay, so just remember, when you go up, it's positive. When you go down, it's negative. When you go to the right, it's positive. When you go to the left, it's negative. And if you can remember that, and you can count squares, you can figure out the change in x over the change in y. And let's simplify this. So when I simplify this, a negative divided by a positive is negative. So you could leave this as -2/1, or we could just say that it's just -2. Both answers work equally well for me. All right, so that's going to be our final answer in this problem. All right, so change in y. So a kind of a quick picture in this one, if you want it, is if I have a change in y, remember that's your up and down. Positive is up, negative is down, and change in x, that's going to be left and right. So left is negative and right is positive, if you want that as a kind of a picture. All right, so go ahead and practice these. You can make up your own problems if you want, or you look in your assignment and you practice these. Just remember, we want to know, how are the x's changing when the y's change? It's just looking for patterns. So all algebra is looking for patterns, and how do we generalize them? All right, have a great day. We'll talk to you later.